All right, in this video, we're going to be going over the study guide for the final exam. And the final exam will be given on the scheduled date and time that is indicated on Canvas for your course, and also on the final exam schedule for the college. Okay. Now, there are 30 problems on the final exam, and also you will be allowed a one-page sheet of notes with writing on both the front and the back. So it's just one page of notes, front and back. And what's on this study guide that I will be going over will be similar to the one that will be on the final exam. Okay. So we can start with problem number 1. Here we got x minus 3 divided by 3 plus x plus 5 divided by 2 equal to 19 over 6. And here we're going to solve this equation. And it is a linear equation with fractions in it. So I'll go ahead and rewrite that equation over here. Now here we want to get rid of those numbers that are in the denominator by finding what they call a least common denominator. That would be the smallest number that is divisible by 3 and by 2 and by 6. And in this case, it's going to be 6, because 6 is divisible by 3 and by 2 and by 6. So in this equation, we're going to multiply each and every term in that equation by 6. So I'm going to do 6 times, and then x minus 3 over 3 plus 6 times x plus 5 over 2. And that's equal to 6 times 19 over 6. And then for each term, we're going to simplify in this equation. So here, if I divide 3 into 6 for this term right here, that's going to go 2 times. So here I'm going to have 2 times the quantity x minus 3. Plus, if I divide 2 into 6, that's going to go 3 times. So I'll have 3 times the quantity x plus 5. And then that's equal to, and here will be 6's, and 6 times 19 over 6, those 6's divide out. I'm left with 19. Now on the left side, I'm going to use the distributive property and combine like terms here. So if I do 2 times the quantity x minus 3, that would be 2 times x, which is 2x, minus 2 times 3, which is 6. And then plus, if I do 3 times x, that's 3x, plus 3 times 5, that'd be 15. Then that's equal to 19. And now if I combine like terms, 2x and 3x will be 5x. Negative 6 plus 15 will be plus 9, equal to 19. So I got 5x plus 9 equal to 19. And then, to get the 5x by itself, I'm going to subtract 9. So now I'm going to be left with 5x is equal to 10. Divide both sides by 5. You'll get x is equal to 2. So here x equals 2 is the solution to that linear equation. And now notice I didn't ask for you to check, but if you have the time, you can do the check if you want to. But here we're going to leave it as x is equal to 2. Okay, now number 2. Here we're going to solve using the quadratic formula. We got x squared minus 2x plus 17. So now we're going to need to identify a, b, and c. Of course, your a will be the coefficient of your x squared term. That's the understood 1. So A is equal to 1. B is the coefficient of x. That's negative 2. Your C is the constant term. That's 17. Now, our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. We're going to substitute a, b, and c in that quadratic formula and simplify. So I got x equal to, bring over the negative sign, your b is negative 2. So we got negative over negative 2 plus or minus the square root of b, negative 2, and that's squared, minus 4 times a, which is 1, times c, which is 17. All that will be divided by 2 times a, and a is 1, so I get 2 times 1 in the denominator. Now let's simplify all of this. Bring down the x equal to, negative over negative 2 will be positive 2, plus or minus the square root of. Negative 2, and you square it, will be 4, minus 4 times 1, which is 4, times 17 will be 68. And that whole thing is divided by 2. Now, if I do 4 minus 68, I'm going to get negative 64. So this will be 2 plus or minus the square root of negative 64, all divided by 2. Now, if I take the square root of a negative 64, that's going to be 8i. The square root of 64 is 8, and there's a negative underneath that, so that means negative 1 is underneath the radical. The square root of a negative 1 is I. And all that's divided by 2. Now what I'm going to do here is break this up as 2 divided by 2 plus or minus 8i divided by 2. It's just another way of writing this term right here. 2 divided by 2 will be 1 plus or minus 8i divided by 2 will be 4i. So my final answer there will be 1 plus or minus 4i. Now you could write it as 1 plus 4i and 1 minus 4i separately. But here, this will be fine if you left it like that. All right, so that's problem number 2. Now problem number 3 is solving the equation by factoring. Here we got x cubed minus 14x squared plus 48x equal to 0. And here we want to solve this equation by factoring. All right, in this case, we first need a common factor that's in x cubed minus 14x squared and plus 48x. In this case, it will be x. So I'm going to factor out the x. And to get what's inside the parentheses, each of these terms will be divided by the common factor of x. So here, x cubed divided by x is x squared minus 14x squared divided by x. That'd be 14x plus 48x divided by x. That'd be 48 equal to 0. Now that x squared minus 14x plus 48, that can be factored into 2 binomials. So here I'm bringing down the x, and then I'm going to factor that trinomial here. That x squared, I can break that up as x and x. And then the factors of 48 that would give me negative 14x will have to be 6 and 8. And they both have to be negative because the middle term is a negative and the last term is a plus. So I got x times x minus 6 times x minus 8 equal to 0. And then we're going to set each factor equal to 0. So this means x will be equal to 0, the x minus 6 will be equal to 0, and the x minus 8 will be equal to 0. Now, each equation I'm going to solve for x. So here, x equals 0 is already solved for x. X minus 6 equal to 0. If I add 6, I'm going to get x is equal to 6. And then for the x minus 8 equal to 0, if I add 8, that would be x is equal to 8. So here, these are the zeros of that polynomial function. X equals 0, x equals 6, and x equal to 8. So those are the values of x that will satisfy that polynomial equation. Okay, that's problem number 3. Okay, problem number 4 is a radical function. Notice it's got the square root here. We got the square root of 5x plus 14, and that's equal to x. And here I want to solve this radical equation. And I'm going to go ahead and rewrite that. Well, the square root is already by itself. So in this case, if I want to get rid of that square root, the opposite of that will be to square both sides. So I'm going to take the square of both sides of this equation. So I'm going to square both sides of that equation. That's going to help me eliminate that square root. And that will leave me with what's underneath that radical. So the square root of 5x plus 14, and I turn around and square it, I'm going to end up with 5x plus 14. And that's equal to x squared. So now I got a quadratic equation that I'm going to solve for x. So here I need to move the 5x plus 14 over to where that x squared is. And I'm going to do that by subtracting 5x on both sides. And also I'm going to subtract 14 on both sides. So when I do that, this will be 0 on the left side, but on the right side, I'm going to end up with x squared minus 5x minus 14. And now on the right side, well, here I've got a quadratic equation, so I can try to factor the right side of this equation. If I couldn't, then I'll have to use the quadratic formula. So I'm going to factor this. This can be factored, by the way. X squared will be x and x. The factors of a negative 14, that will give me negative 5x, will have to be, we're going to try 7 and 2. But here, the larger of the two factors will take the sign of the middle term. So here, that 7 will have to be minus. The 2 will have to be plus. Because negative 7x and 2x will give me the middle term of 5x. So I get x minus 7 times x plus 2 equal to 0. And then I'm going to set each binomial factor to be equal to 0. So this means x minus 7 equal to 0, or x plus 2 equal 0. And each equation I'm going to solve for x. So for the x minus 7 equal to 0, that will mean x is equal to 7. Or for the x plus 2 is equal to 0, if I subtract 2, I'm going to get x is equal to negative 2. So these are my two proposed solutions, x equals 7 or x equals 2. But only one of them is the correct solution to that radical equation, because there can only be one solution. The highest exponent there is a 1. So I need to do the check. So I'm going to start with x equals 7. Now, using the original equation that I started off with, I'm going to substitute each x with 7. So I got the square root of 5x, 5 times 7 plus 14 equal to 7. then I'm going to simplify what's underneath that square root. So here, 5 times 7 will be 35. So the square root of 35 plus 14 must equal to 7. Add 35 and 14, you're going to get 49. So the square root of 49 should equal to 7. And if I take the square root of 49, it does equal to 7. So here this is a true statement. So I can say x equals 7 will be the solution of that radical equation. Now if I did x equals negative 2, if I do the square root of 5 times negative 2 plus 14, that should equal to negative 2. Now if I do 5 times negative 2, that's going to give me negative 10, so the square root of negative 10 plus 14 should equal to negative 2. And then negative 10 plus 14 is 4, so the square root of 4, if I take the square root of 4, I'm going to get a positive 2. Does that equal negative 2? That would be false. So x equal negative 2 is our extraneous solution. So we cross that out. So here x equals 7 is the solution to that radical equation. Okay, so that's problem number 4. Sorry. Now problem number 5 is an absolute value equation. Here we got the absolute value of, 3 times the absolute value of 2x minus 5 plus 4 equal to 25. Now the first thing we need to do here is get the absolute value of 2x minus 5 by itself before we write our two equations. So the first thing I need to do here is move that plus 4 over to the opposite side by subtracting 4 on both sides. So we got 3 times the absolute value of 2x minus 5 equal to 21. And now I need to get rid of the 3 that's in front. The absolute value of 2x minus 5 is multiplied by 3, so we need to divide both sides by 3. Let me make my 3 look like a 3. Now here we keep the absolute value of 2x minus 5. That's going to be equal to 7. And now we have the absolute value by itself. We can go ahead and write our two equations. So the absolute value of 2x minus 5 equal to 7 means 2x minus 5 equals 7, or 2x minus 5 equal negative 7. And then for each equation, we are going to solve for x. So for the 2x minus 5 equal to 7, if I add 5, I'm going to get 2x is equal to 12. Divide both sides by 2, you're going to get x is equal to 6. And then or, for the 2x minus 5 equal negative 7, if I add 5, that would mean 2x is equal to negative 2. Divide both sides by 2, you'll get x is equal to negative 1. So these are my two solutions for that absolute value equation, x equals 6 or x equal negative 1. And you're going to have that possibility with absolute value equations. Now problem number 6. Here we're going to solve the inequality, and in this case this is 7 times the quantity x minus 8 plus 3 is less than 6 times the quantity x minus 5 and then plus 3x. In this case, we need to remove the parentheses by using the distributive property, and combine like terms. So here on the left side, 7 times x will be 7x, minus 7 times 8 will be 56. Bring down the plus 3, and that's less than. Over here on the right side, 6 times x will be 6x, minus 6 times 5 will be 30, plus 3x. Okay, and now combine like terms here. Bring down the 7x. If I add negative 56 and 3 together, I'm going to get a minus 53, and that's less than 6x plus 3x will be 9x, minus 30. Okay, now I would prefer to move the x's on the left-hand side since we're dealing with a inequality. So I'm going to move the 9x over to where the 7x is by subtracting 9x on both sides. And when I do that, 7x minus 9x will be negative 2x minus 53 is less than negative 30. And to get the negative 2x by itself, we need to add 53 on both sides. So here, negative 2x is less than negative 30 plus 53 will be, I think, 23. Yeah. Now, divide both sides by negative 2. When you divide both sides by a negative number in an inequality, that inequality symbol reverses. In this case, it's going to switch from less than to greater than. So you have x is greater than, and I'm going to leave this as negative 23 over 2 as the answer. Okay? So that will be the solution set for that inequality. Okay? So that's problem number 6. All right, number 7 is a absolute value inequality. Here we got the absolute value of 2x plus 13 is greater than 7. Okay, as you can see, the absolute value is already by itself. So that greater than tells me I need to write this as 2 separate inequalities. If it was less than, then it will be a compound inequality. Okay, but for greater than, we need 2 inequalities. The first one will be 2x plus 13 is greater than 7, or the other one will be 2x plus 13. The greater than symbol switches to less than. Positive 7 becomes negative 7. That's how you write the second inequality. And each one of those, we're going to solve those inequalities here, starting with the 2x plus 13 is greater than 7. To get the 2x by itself, we need to subtract 13 on both sides. So you get 2x is greater than negative 6. And then divide both sides by 2. You'll get x is greater than negative 3. Or, for the 2x plus 13 is less than negative 7, we're going to subtract 13 on both sides. That's going to give us 2x is less than negative 20. Divide both sides by 2. You get x is less than negative 10. So the solutions, or solution set to that absolute value inequality will be x is greater than negative 3 or x is less than negative 10. Okay. Problem number 8. We're going to select the graph of a relation which is not a function, is not one-to-one, and is one-to-one. Let's start off with which one of these is not a function. Now, if it's not a function, that means the x is going to be paired with two different y values. So here, this is your x and this is your y values here. So by looking at these three mappings here, mapping B would not be a function because notice your x, which is 1, is paired with two different y values, 5 and 11. So mapping B would not be a function. Now, which one would not be 1-to-1? What I mean by not being 1-to-1, you got a y value going to two different x values here. Between A and C, it will have to be C, because notice 3 has two different x values, -4 and 1. That would not be 1-to-1. Which means mapping A must be 1-to-1. Because you only got one y value to only one x value. That's it. That's problem number 8. All right, number 9. Here we're going to evaluate the function. And this is a piecewise function here. We got f of x is equal to, now we only use 3x plus 9 if your x value that you're finding is less than 1. Or x squared plus 1 only if your x value that you're using is greater than or equal to 1. And we're going to evaluate that for x is equal to 5. Well, that x equals 5 will tell me which one I need to use here. And in this case, I need to use x squared plus 1 because that 5 is greater than 1. So I'm going to use x squared plus 1 to find out what f of x is. So the f of 5 equaling to, replace the x with 5, so it'll be 5 squared plus 1. 5 squared would be 5 times 5, which is 25. Add 25 to the 1, you'll get 26. Okay? So the value of that piecewise function when x is equal to 5 would be 26. Okay, problem number 10. Here we got a rational function. Here we're going to find the domain of that function. F of x equal to 18x squared plus 123x plus 203 divided by x squared plus 5x minus 24. And as I mentioned, it is a rational function. We have a numerator and a denominator. So we need to find out what values of x that will make this denominator 0. Okay? So I'm going to take that x squared plus 5x minus 24 and set that equal to 0. And I'm going to solve for x. Well, it's a quadratic, so I need to factor that quadratic into two binomials here. So your x squared will be x, and I need factors of a negative 24 that will give me 5x. Well, I know 8 and 3 would do it. Now, the sign, the larger of the two factors will take the sign of the middle term. Here, that middle term was a plus, so the 8 will be plus, and I need to subtract, so the 3 has to be minus. So I got x plus 8 times x minus 3 equal to 0. And then I'm going to solve, well, set each binomial factor equal to 0 and solve. So this means x plus 8 will be equal to 0, or x minus 3 will be equal to 0. Each one of those I'm going to solve for x. So for the x plus 8 equal to 0, if I subtract 8, that would mean x is equal to negative 8, or for the x minus 3 equal to 0. If I add 3 to both sides, I'm going to get x is equal to 3. So these are the two values of x that will make the denominator 0. X equal negative 8 or x equal to 3. So the domain in set builder notation will be the set of all x such that x is not equal to negative 8 or x is not equal to 3. And this is fine if you write that in set builder notation. Okay, problem number 11 is writing the equation of the line passing through the points -1, -2, and 3, 6. And here we're going to write the equation in slope-intercept form. I'm going to rewrite those ordered pairs. Now in this case, I'm going to label -1 as x1, -2 as y1. The other ordered pair, x2 will be 3, y2 will be 6. Now to find the slope of that line, which is the first thing we need to do here because we don't know what the slope is, we need to use m is equal to y2 minus y1 divided by x2 minus x1. And in this case here, y2 minus y1 will be 6 minus a -2 divided by x2 minus x1, 3 minus a -1. And then we're going to go ahead and simplify. -6 minus a -2 will be 8, divided by 3 minus a -1 will be 4, and 8 divided by 4 is 2. So the slope of that line going through those 2 points will be m is equal to 2. Now I'm going to use m is equal to 2 as the slope, and I could use either one of these 2 points here. Since I don't like to deal with a lot of negatives here, let's use 3, 6. So if I use the ordered pair 3, 6, then that means x1 will be 3, y1 will be 6. And the point slope form is going to be y minus y1 is equal to the slope times x minus x1. So here you're going to have y minus y1 is 6 is equal to m, the slope of 2, times x minus x1, which is 3. And then I'm going to simplify all of this. Bring down the y minus 6. If I distribute the 2 over the x minus 3, I'm going to get 2x minus 6. And then to solve for y, we're going to add 6 to both sides. So that means y is equal to 2x. That will be the equation of the line passing through the points -1, -2, and 3, 6. Okay, problem number 12. Use the slope and y-intercept to graph the equation f of x is equal to 3/4 x minus 5. Okay, now that function right there is in what we call slope-intercept form. That f of x is the same as y, by the way, so it is in slope-intercept form. I can easily identify the slope and the y-intercept. The slope is the coefficient of x, that is 3/4. The b is the coefficient, it's just a constant term, -5. Or we can write that as an ordered pair, 0, -5, because the y-intercept is the point where the graph crosses the y-axis when x is equal to 0. Now let's go ahead and plot this information on the coordinate plane. First of all, we plot the y-intercept of 0, -5. So I'm going to go down to -5 on the y-axis and draw a point there, because that's the point where this graph is going to be crossing the y-axis. The slope is 3/4. Here the numerator of 3 is the rise. The denominator of 4 is the run. The rise is 3, the run is 4. The rise tells me how many places I go up or down. So at the y-intercept of -5, I'm going to rise up 1, 2, 3 places from that y-intercept. The run tells me how many places I need to go across. It's going to be 4. So I'm going to run across 1, 2, 3, 4. And I'll draw the point right here. That's going to be the other point. Now, all I need is 2 points here. But if you want a third point, you can start right here and go up another 1, 2, 3, and go to the right 1, 2, 3, 4. And connect those points. And that will be the graph of a linear function f of x equal to 3/4 x minus 5. Okay, now this is only going to be part 1 of the review sheet for the final exam. I will have part 2, which covers the remaining 18 problems on another video.